Good morning. Thanks for being here so early. Today we're going to talk about making software more secure, because I think that the foundation of security starts with good software security. If you don't start with secure software, you cannot operate secure software. So we're going to talk about how to fix software life cycles that already exist, because most of the time we do not have the luxury of starting with scratch software where we go in and we say, okay, this is how the perfect security looks for software. So let's build it that way. It doesn't work that way. We start with software and we come in and it's not secure, and then we have to fix it. So today, software is built extremely insecurely. Most of the concern with software is cost and time. So they want to beat the competitors to market, and they want to do it as cheaply as possible. So we rely on offensive testing, which is red teaming, things like that, to find bugs after software is built rather than preventing them. We try to tack on security after it's built. The software developers and creators come to us and they say, here's some software, tell us what we can do to make it secure. And that's really backwards of how it should happen. So we go in and we say, okay, well, we need to put a firewall here, and what ports do we need to open? But it's done after the fact. So we need to start doing that earlier. We also don't fully understand the risk that putting software out there into operation provides. So we don't understand all of the risks that are inherent. We don't understand the risks that it introduces. And we just can't possibly know what's out there because we're not working closely enough with the developers. Also, the people who are making the software don't know anything about security, and they really don't care. They're not taught security, and they don't practice security. They practice time, speed, correctness. So let's talk about how we approach fixing software that exists already. So the first thing we need to understand is who the stakeholders are. Stakeholders are the people that have interest in the software. We understand this. But let's talk about more of a detail about who each of them are and what they care about, so that we can understand how they fit into the ecosystem and how we can change things with their help. So we have to understand people and the processes if we want to make change. People resist change. Computers don't. People don't like change. It affects their jobs. It affects what they do day to day. We need to understand how the process works before we can change it. We can't just walk in and say, okay, let's make a bunch of changes. It doesn't really work that way. So we do try to understand the software and how things work and how things are being done through observation, through looking at historical data and metrics, and then asking people what they think and what's wrong and how things work. So people that are involved in software, this is just some of them. In particular, customers are very important. They're the ones that pay us. The executives are always strong drivers of how things work. And then everybody else kind of works to make sure that the customers and the executives are happy. So security has a very different goal in terms of software than software does. So the builders, the developers, and when I say builders, I mean like developers, software engineers, software architects, product managers, people like that. So they care about it being correct and on time and optimized and things like that. But we want it to be secure. We want it to start secure, be operated securely. We want to prove it's secure for compliance reasons, and then we want to have it documented. But you can see they don't care about those things as much as we do. So project managers are probably the best way that we can figure out how to make change within the life cycle. So project managers, they're like the supervising adults of everyone in the business. So they make sure everybody does what they're supposed to do. They make sure that people brush their teeth and go to bed on time and do all the things that they should be doing. So they manage the schedule from start to finish. If We give them garbage, they are going to produce garbage. So in other words, if we give them bad requirements, no requirements, if we give them bad estimates for how long something is going to take, then what comes out of the project management organization is going to be software that does not include our requirements. So we have to give them good things if we want good things out of the software. So they can help us build security in, but they have to understand what we need. If we don't tell them what we need, then they can't make it happen. So it's a very simple relationship, but I don't think that we're utilizing them the way that we should be today. So QA and DevOps, this is the culmination of software before it gets pushed out into the world. So they use a lot of automation, hopefully. That's the DevOps argument or the DevSecOps argument, trying to use as much automation as possible to make software releases repeatable and quick and easy. So they ensure that the requirements that were set at the beginning were met. Just like software or project managers, they make sure that, that the software meets the requirements. So if they don't have requirements for testing, if they don't have testable requirements, or requirements that are capable of being proven that they're in the software, then they won't do it. I mean, it's another very simple relationship. So we have to make sure that we're giving them what they need in order for us to get what we need, which is secured software. Legal is also a really good stakeholder. They are on our side with things like privacy and confidentiality, liability, risk. They care about a lot of the same things that we do. And they have a lot of clout in the organization. They're probably paid very well. They're generally lawyers and attorneys, and they are very well respected. So what they say, when legal won't sign off on something, that's usually a bigger deal than when security won't sign off on something. I don't know why that works, but understanding that is important because we can work with them and say, look, we have this risk or we have this problem, and we need your help to get something stopped or fixed or whatever the problem is. And they will help us because they have the same concerns. So that's important to understand. Customers have very high expectations that we may not always meet. They care about their privacy of their data. They care about what we do with their data and with their services and making sure they have a lot of trust in what we're doing. And that starts out from the beginning. We have a certain amount of trust that we build up through the sales process and into implementation. And then when they get their services, they have this level of trust. It's very easy to lose that trust. It's not easy to regain it. So once that's gone, once there's a breach, it's very hard to regain that trust. So we need to stay with that. We need to make sure that what we deliver is secure, what we operate is secure. And that includes the software as it's released. Third parties are so important. We see this all the time in the news. When you look at like the Target breach or something like that, every piece of the supply chain has its own piece of the supply chain. So, and that's why it's a chain. So you have members of the chain that have a certain level of security, and they try really hard to secure things. And then you have downstream providers, maybe it's like trash pickup, or maybe it's catering or something like that. And they have less security and they're not trained in terms of social engineering, and they don't, they may use like cloud email or something that is out of their control that we don't understand. But they're still dealing with our payment data, they're still dealing with maybe some of our customer data if we have providers that are doing support for our devices or our software. They may have access into our environments, and we are not properly looking at what they're doing. So our security is only as strong as the weakest link in our supply chain. So we need to make sure that we are auditing them and that we have in our contracts with them that we can audit them and that we can look at what they're doing and hopefully help improve them, because if we help them, it helps us. When we want to look at the existing process, we have to take a step back and walk in and say, what's happening here? How does this process work? How do we get from the idea to the software being in the data center? So we can ask questions, we can look for explanations about why things are happening, we can read existing documentation, we can sit in the as the process and procedure is happening. So we can watch exactly how everything works. We can sit in the meetings, we can be on the email chains, and we can see the process start to finish. And seeing that in its entirety is really important for understanding where the gaps are. When we find gaps, when we find a place where security is not how it should be, or that something is not being reviewed by security, or that there's no input from security, or something like that, then we need to document those and keep track of them and report them and try to fix them. So that's where we're going with this. In a gap analysis, we want to figure out, is there a risk management program? Because if we don't understand the risks, then how do we fix them? Is there a single point of failure? Is there a single person that's doing a task? Is there a system that is managing something that is only in one data center and there's only one system, but it's mission critical? Is there something bad in software that could be fixed? Is there bad architecture? Is there bad coding? Are there good things that are happening? Is there a point where security is looking at software and giving them input and having meaningful interactions with the other teams, because we want to make sure that people know that that's good and that we need more of that. If there are avoidable delays or somebody needs to approve something that could be automated, those are other things we want to keep track of, as well as any security milestones that aren't being met. So let's say that we want to add something to security monitoring something, and it's not happening. We need to keep track of those things that aren't happening. So we document everything, we summarize how everything works start to finish. We write down, okay, here's what I observed. I sat in the meeting, and I mean, you don't have to talk about all that, but you can say, I watched this happen, and these were the steps. So it started out, somebody had an idea, there was a meeting, there was an approval of the idea, and you just walk through the steps. Describe how security is being addressed or is not being addressed within that process that you observed. Write down anything good, like we talked about, list any gaps, but don't just list the gaps, don't just say this isn't happening, say why that's important. So if it's important that security reviews the architecture before it gets implemented, then say why that's important. It's important because if security doesn't review it, then X could happen, or X has happened, or whatever the risk to your business is. And then we want to document the risks or gaps chronologically in terms of the process. So whenever you talk about the next step, if there's a gap there, list it there, and then we'll prioritize them later. When status quo is okay, which it is normally, people have cognitive bias that says, things are fine, let's just let them be. Let's not make changes. Change is very uncomfortable. The same region in our brain that feels pain also feels uncertainty. So uncertainty manifests in our lives as actual physical pain, in very similar sensation. So people don't like change. There are a number of reasons aside from that, but understanding that people will resist change, that will help us in our quest to fix software. So understanding also that everyone has goals, and we talked about some of the stakeholder goals. Understanding that everybody brings something to the table that's different. Everybody has a different reason for being part of the organization, and appealing to those goals. So we know that software wants things to be on time, so let's make sure that everything we ask for doesn't push their timelines back, or that we work with them to make sure that their timelines are not going to slip too much. And we can acknowledge that we understand that you have a brief deadline, or short deadline from now that you need to meet. So we're going to work with you. We're going to give you some extra resources to help you meet that goal. If there are any undocumented processes that happen within your observation of the process start to finish, you're going to document those, because those need to be written down and formalized. If security needs to provide input or review something, then you need to write that. So if the I'm getting an alarm. So if there's a requirement that security needs to provide, then security needs to provide it, and you need to write it down. Same thing with a checkpoint. So if security needs to approve something, then you need to write that down also. Anytime there is collaboration that needs to happen or discussions about something, again, document it. And then this is a maturity model. We're not going to implement all these things. We're not going to solve all these gaps on the first try. It's going to get better over time. So you need a plan to fix things. We have to make sure that security is a requirement for the organization, and that does somewhat come out of the risk management process and program. It also comes from us selling security to the executives and our management and our peers. So we need to figure out how we're going to achieve our goal and work towards that. So one way that we achieve that is with metrics. So we need to understand where we are today so that when we show where we have gone or where we're going, we can have some sort of qualitative comparison that we can do. So understanding the number of security bugs, the types of security bugs, being able to compare them to non-security bugs, trending over time, regressions, things like this, these are things that we can show progress. We can say, okay, since we've implemented this change, we tweak something and then we look at the metrics. So since we've implemented this change, we have seen a decrease in security bugs. That's very easy for executives to understand, and they're like, okay, cool, so every bug costs this much money to fix, and then they can do the numbers and figure out that actually it is saving the business money to prevent bugs instead of fixing later. So metrics do help identify gaps sometimes too, and we can also help attribute gaps to teams or individuals. If there's one person where a whole bunch of security bugs are coming from and the rest of the team is not doing that, maybe we can just train that one person or replace that one person if need be. But we have to actually act on that information and look into it and say, why are the metrics this way? How do we get them, how do we lower those numbers? How do we increase the numbers depending on what we need to do? So we want to be able to show the time that we're not spending on doing something, as well as explain how the investment is being returned. So how much time are we not spending on security bugs since they've been prevented? And that shows the return on investment. So SANS says that if we want to make security a priority, that the CXOs, so CSOs, CISOs, CTOs, whatever, need to understand the improvements that have happened. So when we started at A and we go to B, what has happened? So these are some of the ideas that they think are important for CXOs to understand. Again, it's reduction of things. It's how the business has improved, how the software has improved, because that's what they care about. Understanding what they care about, we give them what they want, and we get what we want. We want to implement the goals and the gap fixes in, let's say, a 3-phase plan. So the first phase is the low-hanging fruit items, the simple fix. So we see something and we're like, okay, you know what? All we have to do is include security in that meeting, or all we need to do is a simple thing. Let's do that, and then that's easy to fix. So we'll get it done. If there are anything critical that legal freaks out about or something, then we want to fix those too, if possible. Phase 1 is also for fixing things, gaps that we find, that could help us in phase 2. Phase 2 is more of a midterm view on how on the things that we want to fix. So if we couldn't fix something in phase 1 because it was not simple, or we needed to take a step before we could fix a gap, then those are the phase 2 goals. These are things that people can wrap their head around. These are things that people can understand, and they say, okay, we can do this within a month or 3 months. The phase 3 is really not necessarily phase 3. It's more of a demonstration of where we want to be. So we've looked at the process, and we've seen some things that need to be fixed, but it's more long-term. It's going to take maybe some head count. It's going to take budget. It's going to take a redesign of something in the software, we can say, this needs to be done, but not yet. Let's focus on these things. Let's get these things done, and then this is where we're going in the future. So it's really for everyone to understand where all of this is going. It's not necessarily set in stone. So we introduce people to the change. This helps people that don't like change, that we ease them into it. We introduce them to the change. We start using our resources more effectively. This is part of the maturity model. We gain support from other people in the organization for fixing things. And then we have the longer term goals where we're just showing where we want to be. We give this to management. So getting management's help, we have to set expectations with them. We have to get their buy-in. We have to make them see how important security is by giving them industry statistics about costs for breaches, about metrics for our own business. We have to give them the goal plan, the phase 1, 2, and 3. And we have to also prioritize those goals and the gaps and say, this is really important and this can wait. So all of that together becomes the long-term plan that you're going to give to management, you're going to give to your peers, everybody's going to look at and say, this seems like a good idea. People can provide input. Getting active input definitely helps with buy-in. When people provide input, then they are inevitably going to support it because they're part of the process now. They're not just bystanders. So when we have objective metrics, those are really influential because they are not biased. I mean, yes, they're a little bit biased towards security, but they're really biased towards the organization. We're not just here for us, we're here for the business, we're here for the customer, really, at the end of the day. So we need to talk about harm to the brand. That can be some of the industry statistics that we get. We talk about that intangible harm to the brand, like how do we get that trust back after it's been broken? Let's prevent that instead of trying to regain it. It's very expensive. We can also explain that as a bug or a flaw moves through the SDLC process, so as we go from idea to design to architecture to development, as we move through all those stages, each time it becomes exponentially more expensive to fix that bug. So as we move from design to architecture, it goes up 5 to 10 times the cost. This is a metric that is commonly thought of in the industry. It's 5 to 10 times as much to fix it as it moves on. So whatever that cost is for you to fix a bug in production, it would have been exponentially cheaper to fix it and catch it earlier, which is why we want to make sure that we fully understand all of the risks that are being moved through the process with the risk management plan, with an SDLC process that includes security. So what needs to be done within the process? That's what we know needs to happen to make secure software. So if we start to think about how software looks and work backwards, we can figure out what needs to be done. Through that, we can say, okay, in order to do each of those steps, who needs to be involved? Is it an approval? Is it a design? Is it something being developed? And then we figure out who all the stakeholders are. Does legal need to approve this? Does HR need to approve it? I mean, does compliance? Whoever it is, we make sure that we note who's involved in each of the things that we are going to give to the software developers when we set expectations. So when we go to the product organization and we say, okay, so here are our requirements for software security. And they take them and they say, okay, so we need to work with these people. It's going to cost about this much. We're going to need these resources. And then they're going to say, so why are we doing this? So we need to talk about why it's important. We need to talk about the metrics and the other things that we are trying to be influential with in terms of buy-in. So we talked a little bit about active stakeholder participation. When somebody is involved in making a decision, they are more likely to support it. So when we can get people involved, when we can get people giving their opinions and making suggestions and giving input and trying to make the process better, then they are going to help us more than they normally would if we were just to leave them out or give them a set of requirements and not involve them in that process. So red team and blue team we're very familiar with. This is an example of two teams working together. It's a really good example of this. They're opposing teams. They have different primary goals. I mean, yes, the ultimate goal is to make the business more secure, but blue team and red team are trying to do very different things. It's a good example of the team working together, but we're not addressing upstream vulnerabilities. We're not addressing the source of vulnerabilities. Why are we having these bugs? Like, why are there so many? We're not looking at the root cause. We're submitting a bug to the developers to fix. They're like, okay, we have this finding, now go fix this. We're not saying, here's why this is a problem. We're just telling you to fix it. So there's also a delay between when it goes into production and when the red team, or offensive security, if you will, tests it. So it will go into production, it will sit there a week, a month, or maybe, if we even have time to run red team testing against software. Because every release, if we're putting out like an agile release every week, there's no time to do offensive testing on that. It just doesn't work. So we're looking for known vulnerabilities with offensive testing, but there's a bunch of problems with this model where we're relying on the red team and the blue team instead of looking at the developers and saying, well, why isn't the software just being built more securely? So we want to be partnering with them, not policing them. We're working with the developers and the software creators to make the software more secure by talking to them, by being part of the same team, instead of saying, okay, well, we found this problem and we had this audit and everything you do is wrong. That's not the way to approach them. That's not going to endear them to us. So we want to have more communication with the other teams. And one of the challenges is actually understanding their goals and them understanding our goals and understanding who to talk to and who does what and how things work. The builders are really, they're part of the security team. They are in charge of security every moment that security is not. So every time software is coded, every time software is updated, every piece of software is touched by developers and builders, even when we don't see it. So we create the design, we create the architecture, we tell them that they need a firewall, but the people that are actually building these components are the ones that need to really understand security, but there's a gap there. So if they can reach out to us with questions and say, I'm building this thing, how am I going to secure it, then it builds better software. Like I said, when we submit a bug, it really doesn't educate anybody. So we want developers to be educated on how the bug is important, how the bug impacts the customer, how it impacts the business, how it impacts the data. We want to have a discussion with the developers to talk about these things, to explain to them that the bug is not just a bug. It's not just a problem with the code, it's a fundamental problem that could affect the business in a really massive way. So sometimes when we talk to developers about these things, they'll say to themselves, well, I used that same function in another place. It may be out of scope for the offensive testing. So they may say to themselves, okay, so I know somebody else that's doing it the same way, or I've always done it this way, why is this bad? Or they can ask questions. The deeper conversations will lead to better software. When we focus on the issue itself and not the person, we're not attacking a human, we're not attacking somebody's effort. We're looking at the problem in an objective way, and we're not making it so that we're attacking their art. Code is art, so I think. So if people spend all of their time making something work, they're building something, they're creating something, and then we come in and we squash it, and we're like, well, this is terrible, and you did it wrong, and you should have done this. That's not that's saying you and you and you, and it's very personal. So if we can get less personal when we present our findings and our requirements and things, that will help us as well. And just being more positive. If we say, we did this assessment, and we hit these roadblocks. We were trying to do this, it didn't work, there was a control in place that kept us from doing it. And then we had to go a different way. We say, we like what you did here, keep doing this, good job. How often do they hear that in an assessment? Like, never. They don't hear good job, they just hear bad, 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 bad. So if we can give them some good things to hold on to use as a model of good practice, then that's really good for us, it's good for them, it makes them feel good that they did something right instead of just doing everything wrong. Nobody wants to feel like all they've done is wrong. So one of the ways that we can get more embedded with developers and builders is to do rotation of jobs, for example. We don't want to cross-train people. We just want to have less formal interactions. We want to have people understanding what other people are doing. If we can have a developer sit on the blue team in the SOC for a day or a week or something, then they will understand better how attacks are happening. They'll get to understand more of a defensive mindset. They'll get to understand more of an offensive mindset, start to think more like an attacker. If developers thought more like attackers, imagine how awesome software would be. I mean, it would just get so much better. So if we're going to start doing this kind of thing with cross-training and trying to get people educated about security that are currently not educated about security, there's going to be a little bit of decreased productivity. There's going to be some resources lost. So management really needs to understand the importance of security in order to buy into that concept, to buy into that idea that if we are willing to give up a little bit of deadline, if we're willing to take an extra day to make software more secure, then we can have so much more. We can have something so much better, and we can have a better product for the customers, and we can help. Our shareholders will be happy. Everybody will be happy. So if we can just get everybody to understand that that a little bit of resource will lead to a great deal of help for everybody, then that's going to be great. I mean, it's really going to lead to good things. So as we start to make changes, we have to set expectations up front. We can't come in at the end of software, just like software shouldn't come in at the end to us, and we say, oh, well, you should have done this. No, if we didn't tell them to do it from the beginning, then it's our fault that time. So we'll make an exception, we'll fix it over time, but we have to set the expectations up front and say, this is what we need from you, this is what we're going to do, this is how it's going to work, here's a bunch of checklists, here's the timeline, here's what we need to make software. And then they're going to say, well, we can't give you that much time. We say, okay, well, what can you give us? And we work with them to create something. But they have to understand what is needed up front, because if we don't, then we're just as bad as they are coming to us at the end of software and saying, make it secure. The PM is really going to help drive this. So as long as we make sure that the PM understands what everybody needs, then that's a good start. Ultimately, everybody should understand what their role is in securing software, but you get there. That's not going to start right away. Policy is the best recommendation I can give you for creating a need other than anything else, because if it's in the policy, you have to do it, in theory. When we have compliance come in, they won't say that you need to build secure software. They won't say you need to have security review all of the architecture. No compliance says that I know of. So they're going to come in and say, let me see your policy, and it says you did this in your policy, so show me that you did that. So if we build secure software and we have security involved in every step, they're going to say, show us that security was involved. Show us the security signed off on the architecture. And then that creates a need. That makes sure that the business does what we want them to do. So if we can have things in our policy that say that security must review every architecture before it goes into operation or into the next phase, then the business will have to do it. So if there is an exception, we do have to have a process for handling that and tracking it. So there will be times when it's just not possible to do something that's in the policy, or there's an emergency or whatever it is. So we need to make sure that there is a process for handling those, but not approving them and forgetting about them. We need to track them and make sure that we go back to them in the future and say, well, we had this exception. Do you still need this? Can we fix this? Or let's reapprove it, or let's reanalyze it. So this is just going back over how we use policy. The policy has to be followed. We're tailoring requirements to meet the policy, just like we're tailoring requirements to meet like our compliances, for example, or good practice. And the PM can use our compliance and our policy to add those things that need to be done. So if the goal is compliance, or well, the goal is security, compliance helps prove that we're meeting that goal, then the PM can help us reach that goal. Knowledgeable humans, I can't say enough about this. I mean, having people over technology is always going to be better. Having people that understand security, who are not on the security team, that's the ultimate goal for us should be. Keeping our knowledge to ourselves does none of us, it just does disservice to everyone. So it's our responsibility to teach everyone else around us how important security is, what good security is, and get there. So what do we need to do to get to that point, to make sure that everybody is knowledgeable about security? Do we have training? Do we develop training? Do we just have people sit with each other? Whatever works for your organization is fine, but we need to have those organizational, that knowledge of security throughout the organization, not just in a silo in security. One thing that we can do to help automate all of this is to use a style guide, which was originally used in print, talking about how you would use letters and fonts and things like that. But you can use that in software to talk about how software is developed. And one of the common jokes is like the spaces versus tabs in code. That's something that would go in the style guide. The company uses tabs. So we can do that with models for security as well. So we can say whenever the organization takes input from a user, we look at it, we strip it of special characters, we analyze whatever. So we can add security requirements into the style guide, and as also standard libraries. So if there's a library that everybody uses, make sure that that's secure, because that's a central point that you can secure many places of code. Talking about the pattern library, this was probably an extra slide here. It does result in more consistent code, though. So automated code reviews are really like spell check. So if you think about the problems that spell check has, spell check is not super good with grammar. It's not super good with words that are acronyms, things like that. So if we understand the limitations of spell check, we understand the limitations of automated code scanning. We want to be doing automated code scanning, sure, that's going to pick do some fixes, but we also want to have knowledgeable humans that are looking at that code, knowledgeable humans that are developing that code in the first place. So yes, automated code reviews are cool and everything, good to have them. It's like antivirus. You have to have it. But you want to have a knowledgeable person working on it. And just so that everybody's on the same page, there is a difference between a flaw and a bug. A bug is a problem with code, and a flaw is more of an architectural problem, a design problem. So when we give a checklist, it does help set expectations with everybody in the business. We talk about what things should look like. We talk about who's going to vet functionality. So we start with the end goal. We think backwards. We want to be secure. We want to be monitored. We want to be automated security. We want to have compliance. We start with those goals. We say, oh, how do we get there? What needs to be in place in order for us to be secure? And that's how we start making checklists. So we give those as early as possible to the PM. We store the checklists and the sign-offs and everything that's been done as an artifact along with the software for the life of the software. We may need to provide that to somebody in the future if our policy says that we do it. So we talk about what software will do, and also more importantly, what software will not do, because that's just as important. So bringing this all together, we don't usually have the luxury of starting with software that has been developed with security in mind, unfortunately. So we're brought in at the end, and we have to secure it. So if we can manage the stakeholders and make sure that that they are going to be our advocates instead of blocking us, that they're going to be amenable to change, then that's a good first step. If we can make sure that security is involved from the beginning, in every single software effort, that's like the biggest step that you can take tomorrow. Well, tomorrow's Saturday, do Monday. So that's the biggest step that you can do. Like the next time you're at work, just talk about like, okay, well, let's get security involved with software from the first moment anybody starts talking about making a software change or developing new functionality. Let's figure out what the gaps are in the process, catalog them, identify them, prioritize them, plan to fix them. Making sure security is involved as early as possible, that we're signing off on everything, that if there is a process, security is involved. No matter what stage of the SDLC, whether it's design or operations, security should be involved. So if we can make small things happen, we can make small changes that have big impact, that's just as important as making big changes. So we need to kind of weigh the pros and cons of fixing each gap. And we're going to phase in change. We're not going to just throw it on people's laps and say, here, we came up with this idea for change, do it. Because nobody's going to do that. They're going to be like, no, I'm not doing that. That's not okay, and they'll just fight it. So if we work with people and we ease them into the change, it's going to be much easier. And making sure that people understand that we're one team. It's not us versus you. It's the organization. We want to have a secure organization. We want to have good software. We want to give a good product to the users. We want our data to be secure. Everybody wins when we have better software. Making sure that they understand that we're not against them. We're not here to give them more work. We're here because we have a goal. We're here because this is important. And that's our job. We need to communicate that.